combination, the alternative word is selections. So whenever you come across the word selections or grouping, you understand that it is a problem from combinations. Whenever in a problem you come across the word arrangement, you know it is a problem from permutations. When you come across the word selection or grouping, you understand that it is a problem from combinations. Okay. Now we'll understand what the concept of combination is. Let us say I have 3 persons. For simplicity's sake, let's take 3. Okay. I have 3 persons. In how many ways can I arrange them? Let's say taken 2 at a time. In how many ways can I arrange them? Anyone tell me?
Sir, 6.
6, but how?
Sir, 3 into 2, sir.
Right? 3p2, right?
Yes, sir.
Which is 3 into 2, 6. Okay. Now let's see what let us now see these arrangements in a little different manner. Now, if I want to choose between two, if I'm arranging these 3 persons taken 2 at a time, that means I have to first select 2 persons, right? Alternatively, you can think of it in this way. In how many ways can I select two persons? In fact, what we say is that we can select the
3C2.
Yes, we can select 2 persons from 3 persons in 3C2 ways. But what is the meaning of 3C2? Let's see. Let's see. First we write number of ways of selecting. 2 persons. Yes, I could not hear you. I could not. Your voice is cracking actually. Number of ways of selecting 2 persons out of this is what we call combinations. This we say just like permutations. We say 3C2, number of ways of selecting 2 persons out of 3. Now we have to find out the meaning of this. What is the meaning of this 3C2? Let's see. Now we have, in how many ways can I select? I can select A or B, right? I can select B and C, or I can select A and C, right? So how many ways of selecting? 3 ways of selecting 2 persons out of 3. Am I right?
Yes, sir.
That is, this is what we call 3C2 equal to 3. Okay. Now, see this 3p2, this arrangement here, we have got 3p2. I am going to make the arrangements in terms of selection, because first we need to select, isn't it? Then we need to arrange. So therefore, now these 2 can be arranged among themselves in how many ways? Factorial 2 ways, 2p2 ways.
Yes, sir.
Each selection, this also can be arranged in factorial 2 ways. This also can be arranged in factorial 2 ways. Each selection can be arranged among themselves in factorial 2 ways, right? So therefore, how many arrangements? What is the number of arrangements? Number of arrangements is equal to each we can arrange in factorial 2 ways. And how many ways are we selecting? 3, right? So what is the total number of arrangements? 3 into factorial 2, which is equal to factorial
6.
3. Factorial
Yes.
3. right? So what you see is that either you do it directly here, 3p2, or when you're thinking in terms of combination, you can also get factorial 3 in this way. Okay. So in now coming to n things, for n different things, what can we write here? If there are n different things, then we can write r factorial for n different things. Let's say selection or arrangement. Let's say permutation. Permutations. Say number of permutations. Number of permutations taken r at a time will be how much? How much is this? How much is this? This is r, right? If we are taking r at a time, because we are taking 2 at a time, right? It's factorial r into what is this? 3c2 ncr. And what is this? npr, right? You understood? For n different things, if I take r at a time, here I have taken 3 people, right? If instead of 3 people, I take n different people, and here I have taken 2 at a time, right? So if I take r at a time, just extending the concept to n and r. So what do you get? We get factorial r into ncr is equal to npr. This is the relation between npr and ncr. Important relation, remember, for multiple choice questions sake. Okay. So therefore, what do we get? ncr is equal to npr by factorial r. And what is the formula for factorial npr? Anyone remember the formula for npr?
N factorial divided by n minus r factorial.
Yes, n factorial divided by n minus r factorial divided by, and you write the r factorial as it is. This is the formula for combinations, remember. Okay. Now every time, just as in permutations, you don't use the formula for permutations to calculate the number of permutations. I have given you a shortcut for calculating the permutations. Here also we have a shortcut for calculating the combinations also. Shortcut is, if you want to calculate say 5c2, if you are doing by formula, what will you do? You will write factorial 5 factorial 5 minus 2 into factorial 2, right? So you're going to write here factorial 5 by factorial 3 into factorial 2. So you're going to write here now factorial 5 in terms of factorial 3. What can I write? 5 into 4 into factorial 3 divided by factorial 3 into factorial 2. So I cancel this. So what am I getting ultimately? 5 into 4 by factorial 2. Okay, now this I have from here, I came here with the help of this formula, isn't it? If you want to remember this from coming from here to here directly, remember it this way. See, 5c2, what is the number here? 2, right? So you multiply 5 with 4. You take only 2 products, 5 into 4. How many products are there? 2 products, right?
Two.
And you divide this by the factorial of this. Understood? So directly you can write this. Let us take another example. If I want to calculate, say 7p3, 7c3, sorry. How will I calculate? How, if you see what is R here? R here is 3. So I write 3 products. 7 into 6 into 5. 3 products and I stop here. Divided by the factorial of this. Are you clear with this?
Yes, sir.
One more example. One more.
Yes, sir.
12C4. Okay. Now, if you have understood, you will tell me. Just tell me what you have understood. Tell me how should I calculate this?
Sir, it will be 12 into 11 into 10 into 9. Then
Yes, 4
divided
products.
by 4.
Factorial
Factorial.
4. Okay.
Yes.
So that is how you find out the value of NCR. Okay. Instead of using the formula each time, you can use this shortcut. Although your calculators, in your scientific calculators, you can calculate NCR from your calculators also. But for certain types of problems, especially for your multiple choice of problems, calculators will not help you much. Okay, for applied problem, maybe the story problems, they may help you, but for such problems, for multiple choice questions, calculators will be of little help. So you will have to remember this. Okay. So that is what. And now let's just discuss the properties of combination. Very important. Now, before properties, yes, very important thing. Note. First is combination of n different things taken n at a time is always one. Why should it be one? Piyush, why should it be one?
Yes, sir.
Why should it be one? Why should NCN be one?
Sir, because we are selecting total all, sir.
Yes, because if there is a class of n students, if I am selecting all the students, in how many ways can I do it? I can only do it in one way, right?
Yes, sir.
So that is why NCN is one. NC0 is also one. Why? Because in a class, if I have n students, and if I don't want to select anyone, in how many ways can I do it? I can only do it in one way, by saying that, okay, I will not select anyone, right? So NC0 is also 1. Okay. And you can also remember this, that NC1 will be n. Okay. NC1 will be n. Why? In a class of n students, I want to select one student. In how many ways can I do it? N ways, right? I can either select student 1 or student 2 or student 3 or student 4 and we carry on till n. So in how many ways am I doing it? N ways.
Anyway.
So that is what these three you can remember. Next is properties of NCR. First property, and a very important property which we shall be using, is NCR is equal to NCN minus R. Okay, this is normally used to calculate where the values are uh, where the values of n and r are very close. Okay, for example, let us say if I want to calculate 12C11, will I write it this way? 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by factorial 11.
No, sir.
This is going to be very long, isn't it? So that is why in such a case, when the values of n and r are very close to each other, we use this. 12C11 will be equal to 12C12 minus 11 from this property, which will be equal to 12C1, which will be equal to NC1 is equal to n, which will be equal to 12. Clear with this?
Yes, sir.
For example, let us take another example. Let us say if I want to calculate 8C5. Now 8C5 values are very close, right? So I convert this to 8C3, 8C8 minus 5. Right? Now it will be easier for me to calculate. 8 into 7 into 6 divided by factorial 3. Clear? Usage is okay?
Yes, sir.
Okay. Next property is called the Pascal's rule. Important for multiple choice questions. Not that you will come across this very often. Pascal's rule is NCR plus NCR minus 1 is equal to n plus 1 CR. This is called Pascal's rule. Okay. As I told you, not a very important relation, but as far as multiple choice questions are concerned, you will have to remember this. Example. If I have 5C2 plus 5C1, what is it equal to? You see that n is equal to 5 here, right? 5 plus 1. C, R here is, let me write this in a, let me add one more
2.
step so that you can understand. 5C2 plus 5C2 minus 1. Now you see this is of this form. So this can be written as n plus 1 C. What is the value of R here? 2, right? So this is equal to 6C2. Clear with this?
Yes, sir.
Let's take another example. Let's say 12C3 plus 12C4. What is it equal to? You can write this as 12C4 plus 12C4 minus 1, isn't it? So that NCR plus NCR minus 1 is equal to N plus 1 CR, which is equal to 13C4. Okay, this is what is Pascal's rule. Now these two are very important results that you must remember. Okay, and I don't think there are any other properties in the textbook. There are other properties also given, but you don't need to remember those properties. Those properties are very trivial. Okay, you don't apply those. Have I loaded the questions? I don't think I have loaded. Okay, just yes, I would like to do one problem here before finishing.